Okay, ladies and gentlemen, let's get to it. All right, as you can see, we are finally drawing to the end of homework 7. It feels like we've spent a lot of time with this homework. It's been around for ages, and now it is finally time to say goodbye, okay? It is due on Monday, and so I encourage you to really get rolling on it if you haven't. It looks like a lot of you have made some really good progress. A number of you are already finished, 100% across the board. Good for you. Well done. You're ahead of the game. Hope you enjoy the rest. And the rest of you, it looks like a lot of you are like 50% of the way through, 60% of the way through, making good progress. I'm not worried for you. But keep in mind, this is a long assignment, okay? A very long assignment. There's lots to do. And at the end, there will be some performance test cases. Not a ton, but some. So you might need to save a little bit of time for some optimization in order to get all those points if you want it, okay? And if you're working on a homework from the past, a homework 6, a homework 5, you're going to want to hit the gas, okay? You're going to want to do what you can to get caught up. As soon as that late penalty kicks in, you're kind of locked into a B- at best, okay? So do what you can, get as many points as you can, and remember, keep your head high, your chin up, because there is extra credit on the way, okay? Especially in this first semester, the extra credit is going to be there, okay? All right, so I look forward to finally moving on to a different topic next week starting Monday. I will tell you, we, the course staff, are very excited to move on to a new topic because we've run out of lecture material for the Homework 7 language hosting topic. We can't exactly move on to physics because then we're basically giving you information before you need it, which all of my 494 students know is just bad game design, okay? And so we're running low on lecture content, okay? And that's maybe getting clear to all of you. These weird scheduling shenanigans won't be here next semester, okay, or in a year when we run this course again. Things will be a lot more polished, and hopefully we won't need to linger quite as long on this homework assignment as we had to this time, okay? But we do have some interesting things to talk about today. I want to show you a really interesting engine that is interesting technically, but also the backstory of this engine is also pretty fantastic, very exciting, in a way, very inspirational. This is Christian Whitehead's retro engine, now known as the Star Engine, an engine famous for basically mainly one title for most people, okay? What is that title? Anyone know? Does this look familiar to anyone? Well, it kind of looks like a Genesis game, right? Sega Genesis is a Sonic game, right? Must be from the 90s, right? What game is this? Anyone play it?
That's Sonic Mania.
It's Sonic Mania. Okay? Sonic the Hedgehog 4, basically. Except not quite, because they tried Sonic the Hedgehog 4. Maybe it didn't go so well, but they tried again with Sonic Mania. And the idea here was that after Sonic had spent a lot of time in 3D, most of the new titles in that franchise coming out in a 3D format, kind of Sonic Adventure, Sonic Lost World, Sonic Unleashed, all that good stuff, Sonic Generations. A team was given the green light to go and make a classic-style 2D Sonic game with new stages, but also kind of revisits and remakes of old stages. And to do this, they basically hired a bunch of fan game creators, okay? Now, that's not quite how it went. Basically, it went like this. Christian Whitehead, a prominent indie game developer in Australia, had been making fan games, Sonic fan games, for a while. And these fan games were posted to places like Sonic Retro forums, okay? This is a place where if you really loved Sonic, if you wanted to make your own Sonic fan game, you could post it here. And other Sonic fans would find it, download it, give you kudos, all for free, of course. And whereas other companies might drop the hammer for making games based on their IP, Sega has been remarkably relaxed about it all, okay? You can go and make a Sonic fan game today. You can publicize it today. Don't sell it, okay? Sega will come after you if you try and sell it, but they will otherwise allow you to go and use Sonic, and learn and build your knowledge that way. And I think that's a really great thing. It was really wonderful for Sega, actually, because basically when Sega wanted to go and make ports of some of their old games, especially for mobile, ports of Sonic CD, ports of Sonic 2, Sonic 3 and Knuckles, they basically turned to Christian Whitehead, who had made a fan game engine that was pixel perfect recreation of the original Genesis titles, down to the physics and how they felt, how they worked, down to the art style, okay, down to the rendering, okay? These remakes are very authentic, but they also bring fantastic new features, okay? Widescreen support, lots of really nice upgrades, great performance, customizable controls. These are regarded widely as some of the best mobile ports of all time. And it's because Christian Whitehead had that wonderful fan game engine, the retro engine, that he was able to do this and do this so effectively. So when the time came to make a new 2D Sonic title, Sega already had their guy. And so they hired him. He put together a team, including some other fan game developers, and pretty soon the fans were making the latest Sonic game. Well, how did it go? That sounds like it could be a disaster. Let's go ahead and see. Sonic Mania Metacritic. 86%. Not too bad. Not too bad. In fact, this is a score you don't see many Sonic games getting these days, okay? Hold on, let's see. What other Sonic games are coming around out around the time? Sonic Forces Metacritic. How did that one do? Uh-oh. Okay, all right, okay. Well, maybe that's just a one-off. Okay, hold on. Sonic Boom Metacritic. Okay, 57. Oh, no. Oh, Sega. All right. So there's a certain amount of irony in the fans finally figuring out how to make a decent Sonic game, and maybe Sega could learn a thing or two. I remember from around this time when Sonic Mania came out, the reception was very good, very good. The game was very well known, and it sold surprisingly well. I remember one of the conference calls, the quarterly conference calls from the Sega leadership explicitly pointed out that Sonic Mania had sold a lot more copies than they thought it would. And so the Sonic team, Sega, have been releasing 2D Sonics ever since. They've released, I think Sonic Origins and Sonic All-Stars, neither of which have reached the same heights as Sonic Mania, partly because they lost the Sonic Mania team. Christian Whitehead went and made something else. They kind of fumbled the bag a little bit, it feels like. Now, it's impossible to know what those negotiations were like. Maybe the team wanted to make their own thing. You know what their own thing was? It recently came out. The team decided they wanted to make, ironically, a Sonic-like 3D platformer. It's a game called Penny's Big Break. You might have heard of it. 76, so not quite up to Mania's reception, but not bad. Better than the Sega games we just saw. And so, a very interesting engine, right? An engine with a very exclusive purpose, and Sega should, frankly, be pretty thankful that it is there, ready to be used. Christian Whitehead also, I think, lended at least some of the engine, some of the techniques to Freedom Planet 2, which is kind of a Sonic-style game. So the engine has gotten around a little bit more than you would think. Originally created for fan games. If the idea of fan games is something that you're not quite used to, know that fan games for all sorts of different franchises is very much a thing. Has anyone heard of Mario Fan Games Galaxy? This is a website dedicated to Mario IP fan games. And interestingly, Nintendo has not dropped the hammer on this site either. Okay? Perhaps because so few people know about it, but this is a place that has been up since I was in, I think, middle school. And I made some games in this community, and I played a ton of them. It's a great community. Learned a lot doing so. This one is very heavily game maker. My understanding is that Sonic fan games, a lot of them were Click Team Fusion. But there are sprite sheets on here. There are new games coming out every month. A great place to learn, build your knowledge, and do so with an IP that's going to get people excited, okay? Even if you can't sell it, all right? And so I think that's pretty much all I've got. If you look online, you'll find blog posts by Taxman himself, Christian Whitehead's kind of online name. And you'll find blog posts where he goes deeply into the physics of how Sonic worked in the Genesis era and how to kind of replicate some of that and get that feel back. I want to show you 2 videos to give you a feel for what they accomplished. This is going to feel like a Genesis game when you watch this trailer. Right? So it is not a simple task to go and remake something from that era in a modern engine, to get the feel just perfect, the look, the personality, the character just perfect. And so that they were able to do this is extremely impressive. Some would argue that Sega themselves have not been able to do this since the team moved on. Very briefly, I'll show you the timeline, a video of the timeline for the engine. This thing really is fairly old. Some of its earliest projects. Yeah, it looks like Sonic. Sonic 1. Sonic 2. Mania Plus. So pretty impressive stuff. Sega, again, is very lucky to have teams that are this passionate about their IP. And unlike some other companies, they didn't just go out and crush them. They, saw it as a potential benefit into the future. So good for them. Good job, Sega. Sega, as a company, has not had a wonderful century. Has had some rough decades. Their fan base is one of those things that's helping them hang on. So hopefully they continue to do so and honor that fan base. Some announcements for you. In this course, we have not had a quiz for a while. Feels good, huh? However, there is a quiz coming. It is on the way. It is coming on Monday, okay? And it will be very largely about Lua, about the language, okay? One of the big wins, I think, of this course, a very pragmatic win, is that you just flat out will have a pretty good feel for an entirely new programming language. One that is not the most popular in the world, but is also one that people have heard of and people still use, okay? And so Lua is going to be a big topic on that quiz on Monday. And in addition to Lua is a topic of how do we use that Lua throughout our game engines. What is our game engine architecture like? How do components work? Stuff like that, okay? This is all to say, the quiz on Monday is going to try and verify how well do you understand what we've accomplished in homework 7. Maybe the most important homework in the entire semester, okay? It's a bit overwhelming. What you've done in the last few weeks is pretty impressive stuff, okay? So I hope you, as hard as it is, as much programming as it is, as much new stuff you're learning, I hope it feels like it's worth your time, okay? You're putting a lot in, and I hope you get a good return on that effort. So we'll have to see. All right, so there's not a whole lot I want to talk to you about today, but one topic I do want to talk to you about, and it's just a small one, okay? Not a full lecture or anything. Just an interesting thing to think about is the idea of exceptions, of try-catch. How many of you have used try-catch in the past? In what context have you used it?
I really try to avoid it, but I mean, I used it in this project for the Lua exceptions.
Yeah. Why do you try and avoid it?
Because unless you're in a programming language like Java, it's really hard to tell what throws, and I'm more appreciative of like errors as values.
Sure.
So I did that philosophy.
Gotcha. Okay. Okay. Things get a bit messy. You start throwing try-catches everywhere. Yep. Yes.
I used it when I was writing the project 2 for 482.
Okay.
Which I was implementing a thread library.
Yep.
And you must make it robust by catching all the exceptions.
Yep. Yep. Using it in a thread library, right? And take note, that thread library that you write in 482, when you think about it, it's really supposed to be an asset for other people. And you have to be careful. As soon as other people get involved, other developers, as soon as you start to serve them, you don't know if they're going to mess things up, right? You have to kind of build it into your software that, like, my users might start writing bugs. How am I going to react to that? We're so used to controlling all of our software. And if we control all of our software, do we even need exception handling? Because we can go in, we can bug test it. If it crashes, we go fix the crash. Eventually, it's relatively bug-free and we're good to go, right? Well, as soon as other people's code gets involved, that guarantee is out the window, okay? Completely. It's a weird feeling, right? Anyway, exceptions are kind of an interesting topic. I want to show you here, in case you're not used to it, it occurs to me that there's not really, in our other courses, there's not usually a requirement to use exceptions. Sometimes you want to use them on a project like in 482, but I think rarely in our courses is there a need, an absolute requirement to use it. Here's an example, right? You have, some code that could blow up. Something could happen. You could get a result that you don't consider to be well-formed, right? So if you've got this line here, and it's basically no line at all, you might want to throw an exception. Or maybe the code does something. Maybe a library throws an exception. Or maybe someone writes some really bad Lua code and it throws some exception. Well, you can either crash, right? Or you can try and catch that exception, right? Use a try statement. As soon as you create a try here, you're basically saying that, hey, if anything bad happens during this block of code, I'm going to provide a handler to deal with that and fix things up, okay? And that's what the catch statements are for. You can put these catch statements after a try block to basically say, hey, here are my functions. This is the function right here that handles the empty line exception. So if there's an empty line, we're going to jump immediately to this code, okay? Here, if we have a more general exception, we're going to catch any exception, and we're just going to print that message right there and then continue to run, okay? And so this is a powerful tool when you want to make your code robust, when preventing all errors is simply not possible, right? You can imagine that you might write some incredible code, but I'm guessing you aren't writing code that's robust against, oops, the hard disk is full. Or oops, someone removed the hard disk, unplugged it as you were executing your program. That's not quite the classes of error that you immediately think of when you're programming, is it? Right? Sometimes you do, right? But those issues can appear where you least expect them, and so you want to be careful. I'll show you an example from the staff solution on homework 7, okay? When we go to run some Lua code, that is user code, okay? We don't have control over that. That could be the worst code on the face of the earth. It could blow up, okay? It could blow up every single frame, and if it crashes our engine, they're going to yell at us. Okay, they might actually think our engine is buggy, our C++ code, okay? And so you can see here that in this try block, right, we check if the enabled value is true, and if so, we call that onUpdate function inside the Lua. And if anything goes wrong inside the Lua, inside that lifecycle function, we're going to catch that so that we don't crash, okay? And we're going to go beyond that. We're actually going to report an error to our user so that they don't think it's us, okay? Hey, it's definitely you, okay? You got to go fix this issue, all right? And so that's how it goes. This kind of targeted, it makes a lot of sense. You can kind of think of this as a sandbox, okay? You know your internet browser, right? Your internet browser, when you write JavaScript, do you have full control of the user's machine when you write JavaScript? You have little bits of control, right? You can upload a file if you want, kind of. But you can't write JavaScript, for instance, that accidentally deletes the user's entire hard disk, can you? Right? That's a good example of a sandbox. The web browser is a sandbox. It downloads JavaScript. It downloads web pages, kind of contains them, quarantines them, limits what it can do, so that, for instance, if you go onto like a really poorly coded web page, it doesn't brick your computer, okay? There's also sandboxing and isolation in other locations as well, right? For instance, ideally, in most cases, one application that's running on your computer kind of is sandboxed, at least to an extent, from messing with and wrecking the other apps that are running on the same time, right? Your operating system is supposed to basically prevent apps from crushing each other. There's still ways for them to do that, but it's a little bit harder, okay? A little bit of a sandbox going on, all right? Don't you kind of feel like, I don't know, it almost feels like you've been elected, okay? You've become an official. You've joined the government, and now your objective here is to prevent users from crushing themselves or bringing the whole engine down. No matter what kind of shenanigans they get themselves into, you have to make sure it still works and the whole thing stands up. Right? It's a very interesting kind of change in philosophy when you go from designing and creating software for a normal end user who's going to click a few buttons, write a little bit of text, to now your user is another developer, okay? You spend a lot of time thinking about programming itself. So anyway, here's another example. So this is in contrast to the example from the instructor solution I just posted, okay? This is an example from the AutoGrader. You want to see some AutoGrader source code? Let's go, okay? Here's your snippet. This is not the prettiest code, okay? Hey, I was on a deadline. One of the big things we teach in 494 is that maintenance and scalability of your code base is a really important thing. But sometimes that deadline is in 24 hours and you got to knock out that code, okay, and just get it running. Maybe you can come back later, maybe you can't, but you got to hit the deadline. Anyway, what you see here is the main grading loop, okay, of the AutoGrader. It's in a try-catch block, and it's a pretty, chunky try block. And the idea here is a bit different. There's a lot of logic that happens in these functions, like is assignment prepared, prepare assignment, right? Grade commit, post or report student graded, right? There's a lot of logic inside of this try block. And if anything goes wrong, then it just comes back here. It basically gives up on grading that student, and then it moves on to the next student, okay? This is, to be honest, a bit of a crutch, and a lot of people aren't super big fans of try-catch blocks because of something like this, right? What can go wrong if you say to yourself, you know what? I'm going to make errors a thing of the past. We're never going to crash again because I'm going to put my entire program in a try-catch block. Bug solved, right? Let's go. Boss is going to be so happy. Our bug rate went to 0. It no longer crashes, right? What's the problem with this? And everyone's giggling, right? You could feel it. In instinctual level, there's something wrong here. Okay? What's the problem?
If you have an exception in like the middle of a function, you could like not do some cleanup or just like leave your program in unexpected state.
Yeah, it might fail cleanup, right? When you have a try-catch block, you're kind of introducing the potential for some pretty weird control flow that you might not expect. That's not great. What else can happen? Okay, look at this. This is actually all right because when an exception happens, it doesn't crash the program. It does put a lot of effort into reporting the issue. But imagine if I wasn't reporting the issue. Because you see this sometimes. It's like try catch, but then in the catch you don't do anything. Yeah, when you have a serious problem in your logic, it just kind of poofs. It silently fails. You might not even know there's an issue happening, okay? So if you do something like this, you have to be very careful to log issues and report them so that these issues aren't just vanishing into thin air, okay? You can run, you can hide, but the issues are still there and they're still going to wreck you eventually. And so one reason you might do something like this, have kind of a root level, high level try-catch block over your entire program basically, is in the instance of a server, okay? A long-lived program where we know there are probably going to be exceptions. Our code probably has some bugs because it's a pretty big program, but no matter what, we can't allow this thing to go down, okay? It has to move on to the next student and hope that student and that submit does not cause the same issue. We'll report the issue, we'll try and fix it later, okay? And this is how the autograder works, okay? If this thing goes down at 3 a.m., okay, the night before a deadline, I have to get up and I have to drive in, okay, to campus, diagnose the issue, fix the issue, reset the autograder. Okay, that's partially my fault. If I was better at this, I would basically remote in to the box so I could reboot it from home. That would save me a lot of time. I'll set that up over the summer. For Linux, we can do that because it's a box hosted in the cloud. For all the other machines, UMich network, after what happened last semester, the UMich network is not excited to let anyone remote in to their boxes on their network. So that's how it be. So it's a pretty interesting topic, okay? You might argue what's better. It really just depends on context. Our engines have a new issue to contend with, untrusted code that we didn't write. We can't guarantee it's perfect, so we have to be ready to sandbox that stuff and respond when it goes wrong, okay? Now, when a user writes buggy code in a game engine, we have a lot of options. It's actually a UX question on how we should deal with this. Now, for you, so far, how have you chosen how to deal with this?
Print out what the spec told me to print out.
You do what the spec tells you to do, okay? Now, I've said this a few times, and I'll say it again. You're not quite getting the same game engine architecture experience that I got making the course. You know why? As much as I say that you're building your own custom engine, that's not quite true, not yet. So far, you've been building my engine, okay? I designed the API, and I made all the requirements for how it will work. But if that's unsatisfying, give it just a couple weeks, because in 2 weeks from Monday, you're going to start on your own custom features. You're going to have a couple weeks to make it your own, at least a little bit. And then over the summer, you can do whatever you want. And I hope you will. I hope you'll customize it and go crazy. But it's an interesting question. What should we do? One option is we just crash the engine. We just crash. No try catch block necessary in that case. And that's going to be really bad. The UX for that is going to be catastrophic. Okay, we're going to have people yelling at us all day. If we happen to get lucky and get popular, we will quickly become a laughingstock, and then people will forget about us. The worst fate. We could catch the issue and ignore it or just move on, the empty catch block. But that's still going to be an issue, right? We won't crash, but suddenly some of our API calls might stop working, or user scripts might stop working. The user's not going to know, was it me or was it the engine? Okay, if it was me, what part did I mess up exactly? It puts a lot of burden on the user. It makes debugging hard for them, okay? We could print an error message, which is a really good idea, right? And I got an example for you, okay? Here's my error message I'm going to print out, okay? Let's take a look. It's very detailed, right? Okay, what's the problem? What's the problem? How are people going to react to this? How do people react to this? When you bring me the crazy compilation bug in your C++ code. ChatGPT, you just kind of copy and paste it. That actually might be able to save us these days. Finally, there's something of a solution. In fact, maybe give it a year. Maybe Visual Studio will detect, wow, you got a big compilation error there. You want to ask Copilot? You want to ask GPT? And you can just click a button and it'll send it to GPT automatically with even more data. And they'll tell you, hey, by the way, like, this is what it's actually trying to say, okay? No, this is awful. This is way too much information. It's not very clear, okay? And so we don't want to do something like this, if possible. This is one of the things that has held C++ education back. People avoid C++ when they see that stuff, okay? Yes?
Or when an error message gives you too little. Because when I was
Yeah.
with compilers, if you had a stack alignment issue, it would just say stack alignment. That's it.
That's
and
it.
Like, I don't know where, when, anywhere.
Brutal. And how much time would you lose?
Hours.
Hours.
Because depending on what the language or whatever what you wrote.
You lose hours, okay? Hours, hours, hours. I want you to imagine for a second that we want to dethrone Unity, okay? How are we going to dethrone Unity? How are we going to dethrone Unity? Well, what if our users of our engine wrote fewer bugs than Unity users? And what if when our users wrote bugs, our engine was better at helping our users fix them faster? The average bug for a Unity user takes them 30 minutes to solve. But for our engine, only 10. It's a small win. It's a small win, but small wins over time, if you can get enough of those turn into a big win. Those turn into reputation, okay? That A2 engine, you know, it's not, it doesn't have 3D, but it's really a dream to use, okay? So when you're thinking about what kind of error message you might want to provide, we have better examples, okay? If you look at Unity, it does a pretty darn good job, okay? It doesn't throw a ton of stuff at you. Maybe most importantly, it tells you what specific line of code caused the exception, okay? In this case, there's a script in our project, sf patrol enemy move.cs, and it happens on line 22. If we double click, we can go there. It'll take us there automatically, right in our editor, okay? It'll also tell us what function the issue happened in. So in this case, the start function, okay? If we had recently been typing in that function, then we can go straight there. We might immediately know the issue, okay? One thing that Unity sometimes struggles with is telling you which actor was responsible. So we know which script, but do we know which game object? Do we know which actor? Because the script might be on many actors. hundreds of actors. But which one caused the issue? Well, sometimes in Unity, and this is kind of inconsistent, but sometimes when you click on the error message, it will like briefly flash a game object in your hierarchy view on the side. And that will tell you which one was responsible, which one is guilty, okay? And so that can be useful to you. But this is the approach that we require in this course. This is an approach that will, number one, it colors the text in your console, which is a really good start, okay? You see red, you know something's gone wrong. The first thing it does is it kind of tells you which actor is guilty here. Amy Chipley, if you're deep in the lore of the game dev courses here, you know that's a familiar name to you. But it tells you the actor name, and then it tells you which Lua script is guilty. It then tells you what line, and it tells you what the issue was. So in this case, I tried to call a function called this function doesn't exist, and the function did not exist. So there you go, okay? The test case I got this from is a bit on the nose. But it's good stuff, right? So it tells the user what actor is responsible. It tells the user what the actual issue is. It colors it in red to get your attention, right? One thing we could maybe add that would be even better is to print the stack trace, which we don't currently do. You just kind of get the top level of the stack trace. You don't really get a feel for what led to that call, all right? So that's a way you could improve this after you leave the course this summer if you wanted to. And it's a small thing. I don't know if you're going to get super rewarded for it. You're not going to get much kudos. But if you can do anything that decreases the amount of time your users spend confused and frustrated and stalled, even by 10%, that stuff builds up fast, okay? You know what Godot's big problem is right now? Godot, it's the open source champion fighting the good fight against Unity, right? Which is unleashing their anti-consumer business practices upon the world, okay? And who will stop them? Will Godot stop them, right? Maybe, maybe not. You know what the problem with Godot is right now? Big problem? Name to me the last AAA game that was made with Godot. Name to me the last big indie title that used Godot. Can any of you do it? If you've ever heard of a game called Cassette Beasts, so my publisher is actually publishing that game as well, and it's a really cool title, and it's relatively big for an indie game, but it's not huge. Can anyone think of any AAA games or AAA-ish games to use Godot? Sonic Colors Ultimate, the Sonic Colors remake, is the only one that I know of. People aren't able to use Godot. They can't use it to get big games finished on time, okay, with big teams. And part of the reason might be that there's some user experience issues, okay? When you're making stuff with Godot, sometimes it's a little bit hard to understand what's going wrong when stuff just doesn't work. So that might be a part of it. Performance is also another thing Godot struggles with a bit. But anyway, this stuff really does matter. And when Godot can finally get some big, well-known, famous hits, when the big game of 2026 comes out and a big Godot splash screen shows up, that's when the engine will truly take off. Does anyone know what Godot's main industry right now is? There are reasons to be optimistic about Godot. One of them is that it does have an anchor industry. Godot wins this market, but it's not one you've thought of for a while, chances are. The word gaming usually means around here, like, playing awesome games with your friends, right? Games that take you places, ask interesting questions. But gaming means something else if you go out to the desert. What does it mean? That's right. When it comes to Godot, it is the engine of choice for the gambling industry. Did you know? And suddenly it makes sense, doesn't it? Because you remember what license Godot has. What license does it have? MIT license, not just open source, but MIT, okay? The most open of open source, which means the gambling companies, when they use Godot, they don't have to worry about some engine developer developing a conscience and saying, hey, don't use our engine for your addictive gambling products, okay? But Godot is open source, right? It's MIT licensed, so the gambling company can do whatever they want, all right? It doesn't matter what the creators of Godot think or feel, all right? And so it has an anchor industry, which is pretty cool. Now it just hopefully can get a better one moving into the future, all right? Anyway, gambling machines, I don't know, have that intensive performance requirements in the first place, so Godot is also a pretty good choice there. Though you'd also expect gambling machines wouldn't have the fastest chips or the best hardware either. Keep costs low. So I'd be very interested to learn more. Anyway, so one thing you might be wondering about is the topic of exceptions and what they do to performance. I was doing a bit of research on this the other night, and exceptions are a little bit spooky for a lot of developers because they can affect performance. Now, it seems to me, from what I've found, I was reading this ISO report, I think it was from 2006, a report on basically how C++ implements certain language features and what, those choices, what impact it has on performance. And basically on page 39, basically we discover that the way that most languages, it seems, at least C++ implements its exceptions, it implements them in a way that does not cost any performance at all. It kind of builds it basically builds some data structures, I think at compile time even, that can quickly get you back to that function, that exception handler function, if anything goes wrong when you're in a certain try block. This is basically at the cost of additional memory requirements, which can be an issue on embedded devices, which just don't have a whole lot of memory. It's called the table approach. You basically create a table that helps you map back to where you need to jump to. It does not cost any performance unless an exception happens, at which point you have to jump around and you have some cache issues as a result of that. But anyway, kind of interesting. If some horrible thing has happened, I don't think performance is usually the biggest concern in the first place. And if you have a game that you really care about performance in, go fix your exceptions. Make sure they don't happen, okay? When exceptions start to fly, you probably have bigger issues to worry about than performance at that point. Anyway, so it seems that you shouldn't be too nervous to use exceptions when it makes sense. And in general, my advice to you is think about when you want to sandbox something. If there's anything in your program that you really don't trust, okay, whether you're communicating and interacting with a network server or something, and you're not sure if the network result is going to come in, or if you're running some user code or some code that you really don't trust very much to be correct, that's a really good case for throwing down a try-catch block. Try and keep it small if you can. Or if you have a very long-lived piece of software, like a server program, like an autograder, that has to be up 24/7, even if it's buggy, even if things go wrong, right? Throw a try block over all that, and then make sure you're being very careful and reporting and logging everything that goes wrong. In this case, whenever something goes wrong, I get an email, actually. It doesn't just go into a log file. It emails me to say, hey, we got an exception on line X when we were grading student Y and their homework, N, right? And so then I can go and rerun it over and over again to kind of reproduce the issue and fix it, okay? Anyway, so does anyone have any questions on exceptions? Philosophically, you're in a very different world. You're making software for other developers. They can mess things up. And so sandboxing is a big deal for you now, okay? And you're going to spend a lot of time thinking about the designer, thinking about your game developer, because you're no longer a game developer, truly. in the first 3 weeks, 4 weeks, you were a game developer. Now, on Homework 7, you are an engine developer through and through, okay, top to bottom. We'll return to being game designers during the final game jam after the course is ended, okay, after the semester is ended, all right? Okay, any questions or comments on exceptions? Okay, cool, very good. That is essentially all I wanted to talk to you about today. Again, these shorter lectures are very much a product of like this being a pre-alpha semester and the schedule getting a bit messed up. So we appreciate your patience and thank you for being guinea pigs. And if you have any questions on Homework 7, the entire staff is here, okay? And so we can walk around and we can help you. And so let's get to that, okay? I'll throw some music on. Let's get you through Homework 7. Homework 8 is going to be a fantastic time. Let's make sure you're prepared for it, okay? All right, we'll see you next time. Take care, everyone on Twitch. Bye-bye. Thank you for tuning in. We'll see you next time for some physics, okay? In Box 2D. See you then.